want to share with you how to enable serverless metrics in Apache OpenWhisk on Kubernetes with Prometheus. I'm from IBM. My name is Chun. So a bit of self-introduction first. I've been working in IBM for more than 10 years. I'm an open source developer. So I've been working in open source community for quite a long time, starting from OpenOffice to OpenStack. Then in 2016, my focus was shifted to serverless. I start with Apache OpenWhisk. And now I also work on Knative, and I'm also a contributor to Knative. So this is an outline for my presentation. First, I would like to talk about how we monitor in OpenWhisk. I will start with Apache OpenWhisk overview. Then I will explain the metrics defined and collected in the Kamon, and also how these metrics displayed in Prometheus. And I will finish with the demo. So beginning to start with, how many of you have heard of serverless? Quite a few. Good. As the cloud computing structure evolves, users' focus have been narrowed down. At the beginning, we need to pay attention to the whole physical machine, then virtual machines, then the focus is on containers. Now the focus is on functions. For end users, they'll need to pay more attention. We don't need on the underlying infrastructure. They can focus more on business logic. And for cloud vendors, they get higher computing speed and better resource utilization. So I think that in the future, we'll pay more attention to more segments. What about serverless? What about its advantages? In serverless, the functions is stateless, event trigger, and it is auto-scaled and even scaled to 0. That means it won't occupy any resource unless you call it. In other words, it is short-lived. This helps us to reduce cost because now the cost is generated by your usage. So without usage, there won't be any charge. And also, developers can pay more attention to their business logic. They don't need to worry about underlying infrastructure. That helps them to focus on the market. If there's any change, they can update their app easily, or they can put their idea into reality easily. So how do you make your own serverless platform? Kubernetes is a well-known platform to all of you, I guess. And in terms of container orchestration, it can be, it's fair to say that it is the unicorn or monopoly in this serverless orchestration. Then you can find an open source serverless project and deploy it into Kubernetes. And there are quite a few projects, open source serverless projects that can be deployed in Kubernetes. For example, OpenWhisk, Knative, and Kubernetes. So this helped manufacturers to lower their cost in terms of deployment on Kubernetes. So Apache OpenWhisk was initiated by IBM. It is now an incubator in the Apache community. The aim is to build an open source event-triggered functionless service platform. So I think the OpenWhisk is quite a well-established project in the community because it has the Apache software foundation, and it is proven on the IBM cloud. So it is quite a mature project. In the OpenWhisk, it encouraged event-driven programming. The event trigger action, there is an input, then it will activate an action which is called coding. And the coding supports the common languages like Java, Pythons.
现在呢，就是 Apache OpenWhisk 它的部署是可以部署在任何支持
The Apache OpenWhisk can be deployed on any Docker-supported platform.
只要支持 Docker 平台就能去部署。那其实呢，我们也是支持在 Kubernetes 上去部署的。
So Apache OpenWhisk can be applied in Kubernetes as well. We have a project through the Helm, then you can deploy the Apache OpenWhisk on Kubernetes. This is the structure for the deployment. So you can see the core modules of OpenWhisk. On the left is the user rent. We can skip that. And followed by the Nginx. Nginx is an API gateway. It will transfer the request into controller. And the controller will send the request through load balance to Kafka, and the Kafka will send it to Invoker. The Invoker will call the container and put in the code and execute it. Between controller and Invoker, Kafka helps with the communication between the two. And all the data is saved in the CouchDB. And on the top, you see a Zookeeper. It is installed together with Kafka. So based on this structure, there are two core modules in OpenWhisk. One is controller, the other is Invoker. And other than that, the Kafka and database, these are also important modules. So this is the typical user cases in Serverless. Serverless in itself is a microservice platform. The code can run on this platform, and this code runs in stateless status. Therefore, the serverless itself is a microservice platform. You can implement fine-grained microservice APIs on it. It is also suitable for the large number of events, or the events or the functions can be put on this serverless platform. And it also has the DevOps. Your code upgrades can be used on this platform as well. So metrics is very important on serverless. Not only for serverless platform, because for serverless, that means developers are far away from infrastructure. Maybe the developers are not experienced IT workers. For example, a painter wants to write a code to process his or her image. So for these amateur developers, they know something about Python or some basic languages, and they want to know, after the program is put on the cloud, how the program can run on the clouds. They have no idea. Therefore, monitoring is very important, especially for serverless. Therefore, for metrics or telemetry, that's the only way for such developers to understand what happens on the server.
And for the cloud companies, the metric is really important because it's useful to understand the system health condition, and it is necessary to enable measuring and billing. So metric is really important. So how do we define the metrics in the OpenWhisk? OpenWhisk distinguishes between system and the user metrics. System metrics typically contain information about system performance. In the system metrics, it will collect via the open source project called Kamon, and all these system metrics will usually used by providers and operators. Another metric is the user metrics. It contains information about action performance. In the OpenWhisk, we will use it as an event and send it to the Kafka. So in the Kafka, you'll receive a lot of the message, and all these messages are the information of the action performance, and it is consumed by the OpenWhisk users, and it can be used for billing or audit purposes, but we don't expose it to the users directly in IBM functions, and you can use it via the user interface, and all this info can also be used for the audit and billing at the same time as well. And later, I will focus on the system metrics. For the user metrics, its realization in the OpenWhisk is different, so I think it's another topic. So let's focus on the system metrics. Why did we choose the Kamon to be the open source monitoring framework? OpenWhisk is written by Scala, and Scala is based on the Java. And also use another Java base. It's called AKKA, which is the distributed communication software. And in the OpenWhisk, when I choose that, what can I use to collect the metrics and to record metrics? At the time, we chose the Kamon because we thought that Kamon is a really outstanding metric collection based on the JVM, and currently it has already been able to support the Scala and Akka. So that's why we chose the Kamon. There are some features of the Kamon. For example, it has a really powerful matrix. It can be distributed. It can be able to use for distributed tracing and context propagation APIs in a single library, and also provide different metric recording instruments in its core metric API, which will be covered later. When we switch the recorder, we don't need to change the matrix index. And currently, the Kamon is also improving and optimized as well. Therefore, it can work with some really popular monitoring tools such as the Prometheus and the ZipGit. So I think that the Kamon is really convenient to use. It's just an API, and an API when we write code and when we need to make the metric and what kind of metric indicator we need to collect. And everything can be defined, and then all these metrics will be collected by the Kamon. So let's have a look at the Kamon metrics instruments. Well, actually, it provides different kind of the instrument. For example, the counter counts how many times it was in increments during a recording period, good for counting errors or occurrence of the specific events in your device. Another one is the gauge, which is the metric value, and track a single value that can be increment, decreasement, or explicitly set. Good for slow-moving variables such as the available memory and disk usage. And the next one is the histogram. Track. It is quite complicated metric. It can track the entire value distribution of a given metric within a specific time. It is good for the array or the queue. So the data of the queuing is, or the number of the people of the queuing is changing from 1 to 10 or from 1 to 5. So during this period, what we need to count? We need to count the min value or the maximum value or the minimum value. But with the histogram, it can record all the data, all the values we need. It also helps the data structures enable it to be stored in a really smooth area. So if you are interested, you can read all these documentations of the Kamon. Well, the next function is the timer. It allows you to start and stop the timer. And another one is the range sampler. So all these are the instruments. And the third one are used quite often in the OpenWhisk, but we don't use the last two in the OpenWhisk. And in the OpenWhisk, the matrix are from the controller and the invoker. All these matrices we call the execution of the user code is called activation. It will monitor the activations, memory usage, Kafka database, and HTTP requests, and etc. There are over 60 metrics till now, and currently I only give you some really typical case. For example, counter. We use the counter to port the count of the activation set to Kafka.
就是我们记录了发送给 Kafka 的这个 activation 的这些消息的次数，也记录了
And we also use it to record the count of the non-blocking activation started.
计数器主要是用来记次数的。
So the counter is used to count. Another one is the gauge. We use it to record the
去记录就是在一个controller 的
to record the number of the activations being worked upon for a given controller.
通过计量值来记这个，然后计量值还记录了就是在一个 activation 里边有多
The
少个
amount
memory 被
of
使
the
用到了。
RAM memory is used for the flight activations. For the histogram, we use
invoker
it.
的这个invoker 的这个管理的这些
We use its invoker to manage the memory usage, and we also use it
完备的，就是已经完成的 activation 的数字。
to record the numbers of the Kafka topic to receive activations to complete. And after all these kind of metrics, so let's look at the Prometheus. Kamon is only a library. The purpose is to collect the matrix for you. After the matrix is collected, you need to store it somewhere else, right? In the past, we used the stateless, and currently we treat Prometheus as an alternative. Prometheus is an CNCF project. It's a system and service monitoring system. It collects matrix from configured targets at given intervals and evaluates the rule expression, display the results, and can trigger alerts if some condition is observed to be true. So I think that it is quite a complete monitoring system. It also has a lot of the advantage. For example, it has a really powerful data searching language, and it's not rely on the distributed storage. And the time series collection happens via a pool model over HTTP. And in order to get the monitoring data, we can use the static way and dynamic way to find the exporter of the report. And it also supports different kinds of the diagrams. So let's see that if we use the OpenWhisk, or if we use the OpenWhisk matrix, if we use the Kafka to collect the OpenWhisk matrix and see that whether we can compare and we can find it to the Prometheus as well. And let's have a look at this one from the middle. The Prometheus core is the Prometheus server. In the server, the retrieval module is to collect the matrix. There are two ways. The first one is to pull matrix, and when they collect the matrix field pool, it must have the exporter. The matrix must be exposed to the pool, and the retrievers can get all the matrix. And it can also use the push method to collect the data. But there are some short-time tasks. For example, this kind of task only lasts for about several seconds, but the process will take you about 10 seconds. In this way, you will miss a lot of data. In this way, we have the gateway, and the temporary storage can be transferred to pool, and then it can be collected and stored in the memory. So we can use the query of the Prometheus to search it. On the right-hand side, the module is called Alert Manager, which means that when some condition happens, the alert will be sent. They also have the web UI and API clients. All the thing has already been available. So let's look at the service-defined detected module. Beside the dynamic one, we can also use the label method to find all these kind of the abnormal conditions. In the Kamon project, we developed a Kamon Prometheus exporter, which is an open source project. The data is written below. It supports the integration of the Kamon and Prometheus. It is really simple. As long as you add a really simple statement, the matrix connected by the Kamon will be converted to Prometheus format and exposed to the HTTP address, or exposed to the HTTP address slash. Matrix, and in this way, this kind of matrix can be consumed by the Prometheus, and you can add some statements in the Prometheus, which will enable the Prometheus can pull the data from these terminals. So that's all the statements that we add to this project. So let's have a look at this diagram. We only take the OpenWhisk controller here, but currently we expose both the controller and the invoker. In the controller, we use the Kamon to collect the matrix. We'll use the Kamon and Prometheus exporter to expose the stress slash export to abroad. And when I use the Prometheus, the retriever will just pull the data from these terminals or these sockets. And this way, the matrix can be shown on the interface of the Prometheus. And later, I'd like to give you a simple demo. In the target, you can see that the controller and the invokers has already got the matrix respectively. Well, now I'd like to give you a really simple demo. Well, actually, the demo has already been installed properly, and I mean that the Kamon and the Prometheus project has already been installed. So I just want to show you the result. Well, actually, this one is stored on the cloud, so maybe it is a little bit slow.
So here, it got the data of two edges, and here are all the metrics. The one started with the counter. The C means counter, and gate means measurement. And here is the diagrams. These are the metrics collected. Let's pick one. This is monitored by the controller and send the time for the activation, which is sent to the Kafka. And for counters, basically it's a value, either 0, 1, 2, something like that. So this is 2. Basically it's a number. It indicates how many topics are studied. So that's the demo. So this is the demo, and that's the end of my presentation. If you have any questions, feel free to raise your hand. If not, can you use the microphone, please? If we want to write a function on FaaS platform, and maybe this function need to connect to the third party, like object storage or Elastic or Kafka, then will you provide some resources, and also there may be a huge number of code. Well, for the functional service, if you use object storage, we will suggest you to use cloud service to do that. For example, use the RESTful API, call that. If you can use the third-party existing services, then just use that service. If that service is not available, then you can bundle your code and database, and that would involve a huge project. So what about IBM? I mean, if I use the IBM serverless, then will IBM provide some reliance service for us? Yes, IBM's functions are integrated with IBM's cloud service. So if you use the services on IBM Cloud, it's very convenient. Thank you. So after listening to your presentation, to my knowledge, so you use the exporter to provide some metrics for monitoring for Prometheus. So for the image display, do you have any measures in this regard? In our community, there's a developer developed the Grafana interface, but not on Prometheus. So, okay, I understand. Thank you. Okay, one more question. Thank you. One more question.
IBM 上面会提供我们那个结果的监控嘛，就是日志。
So will IBM provide some result tracing or monitoring? Yes. What about alert system? Alert system is also available. Thank you.